Great. Well, thank you very much. This is the second day of the conference, and it's almost over. So those of you who have made it this far, congratulations. By now your brains are full, and you're keen to go home. You've got things to do, not stay here. So I'll do my best to try and get through the material as quickly as possible. Just a few slides about me. So just to say who I am and what I do. So that's me. So my background, I'm old guy, gray hair, white hair, no hair. It's like that. I've seen it, done it, got the T-shirt. In my IT career, pretty much everything. So I started life as a developer a long time ago, working for Reuters in London, real-time systems, relational databases, and then subsequently was an academic, consultant, and then worked for a few other vendors. I had the great privilege at Informix to work for Mike Stonebreaker. Mike is a name, if you know anything about database systems, his name will be very familiar to you. So he's the guy who invented Ingress, Postgres, SciDB, VaultDB, Tamer, Vertica, ... The list goes on. Fabulous gentleman. So great academic, based at Berkeley for a long time. These days he's at MIT. Not quite so active because he's quite an elderly statesman these days, but still, he publishes from time to time. Worked for IBM for a long time, and I was involved in developer relations and academic initiatives. Subsequently got into the big data space a few years ago, so I worked for Hortonworks, Hadoop, for data stacks on Cassandra, and then I was an independent consultant, so I worked for a couple of companies, VaultDB, MongoDB, and did some consulting with them. About a year ago, GridGain came to me, and they said, we have this job, we would like to offer it to you, okay, so we need someone to help raise awareness of a technology called Apache Ignite. And I was a little bit surprised. So I knew nothing about Ignite. I knew nothing about GridGain. And so I was kind of pleasantly surprised that someone wants to pay me money to talk about open source. And so I feel I've got the best job in the world now. I actually get paid for speaking about open source. Not bad. And so in the early days, when I was learning about Ignite, it's kind of evolved, even the short space of time that I've been there. And so originally, it started life as an in-memory data grid. And you may be familiar with some other commercial technologies, such as Oracle Coherence, for example, Hazelcast. There's a few others as well that you may be aware of. Well, Ignite comes from that kind of space, if you like. But during this past year, it's evolved significantly. So now, it supports SQL 99, for example, and you can treat it as a distributed SQL database if you want. It's got native persistence. So rather than just working with an external third-party database system, be it relational or non-relational, you can actually persist data directly within Ignite. It does machine learning, okay, which is the presentation we're going to focus on today, and we'll talk a little bit about some of its capabilities in that space. Okay, so broadly speaking then, as I said before, been there, done that, got the T-shirt, lots of things that I've done through my career. Very fortunate to have had the opportunity to publish a number of books as well. So these make wonderful gifts for family, friends, loved ones. If you're looking for anything to give to people at Christmas, Hanukkah, any time of year, birthdays. So seriously though, don't buy these, okay? Look at the titles, Object-oriented databases, who uses them? Nobody, XML databases, who uses them? Nobody, all right? So that's the nature of technology, Things come, they are around for a while, and then they go, Something else comes along. So the hot technologies, the hot things people are talking about today, NoSQL, MongoDB, yeah, you're probably, you guys are probably using some of those tools today, but, that's life. One of the things that my boss got me to do, Dennis Magda, so Dennis is the PMC for Ignite at the Apache Software Foundation. He's the guy who runs the program effectively. And so he got me to write some articles, And so if you have the opportunity, just pop along to dzone. There's about, I think, 19 articles have been published during this past year. So initially, as I was learning, I was just writing about what I was learning, okay? So sharing what I had learned with others. Especially this year, it's got a little bit more technical. So we talk about things like recovery, failure, what happens to a primary, a secondary, what happens if the client fails, and you've got jobs submitted, and as you know, distributed systems are hard to build, and they are hard to recover. But if you use things like two-phase commit, which is very well understood and very popular, and it's a technology that's very widely used, then things become a little bit more easier. So some stuff there. And more recently then, so let me just end this one and just quickly switch to the web browser just for a moment, okay, and then we'll get into the main presentation. So over the last couple of weeks then, there's an article on genetic algorithms. I'll show you a demo of that today, okay? So Ignite now supports some genetic algorithm capability as part of the machine learning effort. I just wrote an article on Introduction to Machine Learning. This was published on dzone very recently. And then there's another one, I've just written one on linear regression, okay, which is available on GridGain, hasn't been published on dzone yet. It's going to be hopefully very soon. Other things, let me just point this page, okay, so this is the landing page for Ignite at the Apache Software Foundation. Now notice, it says here, database and caching platform. So in-memory data grids, IMDGs, tend to have a kind of a, the flavor is kind of caching. So if you're familiar with cache technologies, such as products such as Redis, for example, or others, you know what they are capable of doing. The thing is, what you need to remember is that an in-memory data grid does far more than just caching. So for example, Ignite supports transactions, okay? And it can do optimistic transactions, it can do pessimistic transactions. Depends on your use case. And if you work in the financial world, for example, you will know that pessimistic transactions, locking, the need for a system to move from one consistent state to another consistent state is very, very important, okay? Because these guys, they deal with, literally trillions of dollars every day in terms of work that gets shuttled around the world. And just to give you an idea of why it's important, just from my own personal experience earlier this year. So I'm a great fan of MOOCs. I like these massive open online courses, Coursera, EDX, there's a whole load of them. Earlier this year, I was on the Coursera website, and there was a particular course that I happened to like, and I was keen to get the certificate for this. I got my credit card out, filled in the details, I hit the submit button, and it comes up with an error. It says, there is an error. Contact Coursera. Okay, I didn't think anything of it. It's an error. The transaction didn't complete. No problem, all right? Sometime later, I check on my bank statement. I notice that I've actually been billed. So, contact Coursera. They say, we haven't received the money. The bank has charged me. Where's the money, There is a case of a poorly designed system, and I feel that Coursera could do better. So in this type of scenario, either the transaction completes, they take my money, and I get correctly billed, or it doesn't complete, I don't get charged. It's kind of it's stuck in the middle there, and so it's my responsibility now to sort this out. Okay, that shouldn't happen. And again, if you look at things like transferring money between bank accounts, so I want to send my wife, say, 100 euros or 1,000 euros, it should be the case that my account is correctly debited, her account is correctly credited. We can't have the situation where the money leaves my account but doesn't reach her account. This is an inconsistent state, not good, okay? This needs resolution then subsequently. You have to figure out what you're going to do in these scenarios. And so it's an atomic unit of work. So Ignite can do these type of transactions, and it can do them in memory. The other thing is, and we'll get to this a little bit later on, is that because of these additional capabilities that they've added this last year, especially the support for SQL 99, so if you're familiar with some of Google's technologies, Google Spanner, for example, Ignite is kind of similar to that. Cockroach DB is another one you might be familiar with, okay? So these are SQL-based products that can work in a distributed environment, and this is the kind of thing that Ignite can do today. Okay, so a little bit more about that later. All right, so let me drill down now and we'll do the main kind of presentations. Okay, so I've talked for about 10 minutes there, so just keep an eye on the time. Hopefully you'll be able to see that without too much difficulty. Sorry, it's the font's maybe a little bit small, but it says in-memory performance, durability of disk, and I'll explain that in a moment. Now, obviously, the focus very much today is talking about some of the machine learning capabilities that Ignite can do, and then in terms of agenda, so I'll give you a little bit more of an overview and look at some of the components that Ignite supports, and then if you're interested in sort of machine learning or as a data scientist, some of the capabilities, we'll look at the memory-centric storage, the compute grid, machine learning, genetic algorithms, and I've got a couple of very simple demos to show you as well. I mean, this is code that you can download and build yourselves, you can try out yourselves as well. And as part of the articles that I'm writing around this whole machine learning thing, some of my colleagues at GridGain are contributing as well. These things are hosted on GitHub, very easy to download. And if you're familiar with Java, then it's very easy, okay? So, all right then. So the high-level picture is kind of like this, okay? So notice that we've got here this memory-centric storage, okay? So this is really at the heart of what Ignite is all about. And historically, where it came from as an in-memory data grid, very much the focus was on trying to achieve two things, scale and performance. Okay, so the ability to use cluster computing to scale up, okay, use parallelism, use the power of the cluster to be able to work across large amounts of data and be able to cache that data as well. More recently, the persistence capabilities have been added, so it can natively persist data now as well. Okay, so in the event that you've got some type of catastrophic event that happens, let's say your entire cluster goes down, the state can be saved and the things can be brought back up again very quickly. That's the key, one of the key advantages there. And in this mode, you can treat again Ignite as a distributed database system. Okay. It will work with third-party stores as well. If you have a transactional product, typically that means relational, then what Ignite can do then is act as a cache for that relational system. So, and it will keep its cache, whatever it has in memory, plus the backend database in sync, okay? Cache consistency. So, it can read data from the relational system, okay? And you can define which tables you want it to manage and so on. And as transactions are completed in memory, it will ensure that the backend relational system is updated. And if there are changes within the relational system, these are propagated to the cache as well. So the two are always kept in sync. And if you'd like to have a sort of quick look, 10 minutes of your time, the web page, the landing page that I showed you at the Apache Software Foundation, top right-hand corner, it says screencasts, okay? So just drill down, and there are 3 short 3-minute, 3.5-minute videos, 3 of them together, about 10 minutes in duration. It shows you exactly how to do this using MySQL, okay? So you just walk through a series of steps. It creates a project for you, and then it will maintain the consistency of the data that it has in memory and also with the backend relational system. This can work quite well in certain scenarios. So the situation is that very rarely today do we have the sort of freedom and the option, if you like, to just throw away an existing system. Business systems have value. We have to care for them. We have to love them. You know, they have to be maintained. There is information there that we need to access. So in this kind of mode, what Ignite allows you to do is to be able to work with transactional systems, scale up, improve performance. And just to give you a quick example, so earlier this year, I was in Brussels, in Belgium, and I did a sort of general presentation about Ignite. And there was a gentleman in the audience, he came to me at the end, he said, we're very interested in this because we are a big Postgres user, and we like Postgres very much, so we're not going to get rid of it. For the vast majority of our use cases, it works well. There are some queries, though, where it's very, very slow. And so something like this can really help, because then Ignite can scale out that query. It can run that query at memory speeds. It can do parallelism. There's some tricks and neat things that it can do to really be able to push that performance level up. Okay, so in that situation, an existing system can be augmented, and we can use Ignite to improve that. You'll notice that it also says HDFS and NoSQL. Yes, it will work with these technologies, these Cassandra, MongoDB technologies like that. Bear in mind, though, that the vast majority of these NoSQL products are not transactional. They use things like eventual consistency, although MongoDB have announced version 4 of their technology, which is going to support the kind of capabilities that you're used to working with relational systems. Okay, so slightly higher then, from left to right then. So SQL 99, so it's always had some level of SQL support. Now, the thing is, why go for SQL? Well, the thing is that, whether you like it or you hate it, possibly some of you hate it, but SQL is intergalactic data speak. It's used by lots of business intelligence tools. There is a wide range of skilled people available today, both in terms of DBAs and developers who are familiar with the language. Therefore, it's easy to find people with the relevant skills to be able to use it. It's actually very, very powerful as well. I mean, it's a declarative language. You say what you want, not how to get it. The system figures out the best way to be able to retrieve the data for you. And using this in a distributed environment, of course, there are some issues to think about. So, for example, one of the things that Ignite can do is this notion of co-location, affinity keys, okay? So data that kind of is used together can be co-located together on a particular node. And therefore, that saves the overhead of searching your entire cluster when you want to do joins or queries across a large range of data. If you've taken some intelligent decisions about how that data is located with other data, then those queries can be really sort of significantly speeded up. Key value. So at its heart, it is a key value store. So if you've worked with things like Redux, for example, it's a very same sort of approach. The key thing to note here, though, is that the value can be anything. Okay, it can be simple types, can be user-defined types. So you could have, for example, financial instruments or healthcare records, anything you want, okay, as long as it's definable. Now, Ignite is written in Java, but it supports C++ and .NET as sort of first-tier languages as well. Other languages are supported as well, but typically through JDBC and ODBC, all right? There is work underway to provide better support for languages such as Python and Ruby and so on, using this thin protocol that they call it. So if you're familiar with how MongoDB have done this, they have a great plethora of community drivers for their product. That's a great way that they've done this, because they've defined this protocol and then people just write the code to the APIs, to the protocol. They're taking a similar approach now with Ignite. We mentioned transactions, okay, so again, very, very useful, so both optimistic and pessimistic, okay, so optimistic, and then, of course, things like how do you deal with situations where the same resource is being requested in a transaction, in one transaction and another transaction, okay, so dealing with deadlocks. There's, again, code examples to show you how to do this, okay, so all very capable. Compute services, we won't say too much about. Streaming, so it's not a streaming engine per se, okay, but it will work with streaming technology. So if you're using things like Spark Streaming, for example, Flink, these type of products, Ignite will happily work with these, okay? So there are adapters and connectors for these technologies. So Ignite can act as a sink for stream data, okay? And if you use it purely as a cache, there's a lot of things that you can do, okay? So as data are being streamed in, you could run SQL across that data. You can define windows. You might say, okay, I'm interested in the last kind of 5 events, or I'm interested in the last 3 minutes worth of data. You process that quickly. So IoT type applications, for example, maybe sending in lots of stream data. You process that quickly. And again, the other thing to note here is that you can apply machine learning as well. Okay? One of the benefits of all of this is that they say in English, the whole is greater than the sum of the parts. So you have these various components, but they're integrated, they work well together, and therefore, if, for example, you're using the streaming capability, you might want to run some machine learning on that stream data as it arrives, or you might want to do some SQL queries on it as it arrives. Entirely possible. That's very easy. And then the machine learning at the end there. Okay, so that's what we'll focus on moving forward now. Lots of verticals to look at. Okay, so plenty of examples both on the Ignite website and GridGain. I ought to make clear that my role is that I focus purely on the open source. Okay, so I don't talk about GridGain very much. Obviously, they pay my salary. That's good. And so if you're interested in any of the commercial aspects of this, drop me an email. Okay, so it's just first name dot last name at gridgain.com. So akmal.chaudhri at gridgain.com. I'd be very happy to put you in contact with the relevant people. Okay, so why go for this kind of machine learning approach? What's the business case for adding this capability? Because today, pretty much every vendor is adding machine learning to their products. You've got a great choice available out there. You might be using Spark, for example, ML-lib, okay? And then you might think, okay, Ignite looks interesting. But not interesting enough, what's the benefit that I get working with this? Well, the key thing is that in the past, customers, users of Ignite, what they've had to do is that it's been an expensive process, ETL. You have to extract the data out of Ignite, use some other technology or tools to be able to create training models, and then you deploy that into production. And if you're working with large quantities of data, it's an expensive process, not great. So part of the reason for adding this machine learning capability is really to support the needs of users so that everything is in place. Basically, Ignite can manage it for you. It's already managing the data for you. Why do you need to extract it out and run other tools and technologies on that data to be able to achieve what you want to do? So no need to move the data out now for training purposes, no need to wait for that training to complete. Again, can be done entirely within Ignite. And again, whatever models you create, you can deploy them straight away and utilize them straight away. And again, some of the articles that I'm working on show these kind of capabilities. The other thing is scalability. So I touched upon that a little bit earlier on. So today, big data, people talk about the vast volumes of data that organizations collect. Interestingly, I kind of wonder what people are actually doing with this data, because I think there was an article either in the Harvard Business Review or I think MIT Review or something a few years ago that said that only something like 0.5% of all data that organizations ever collect is ever analyzed. The remaining 99 point whatever it is just sits there. That's kind of rather astonishing, because there must be an enormous amount of business value there. And therefore, with this huge amount of data that sits there, it typically exceeds the capacity of what a single server can do. And so using cluster computing, cheap off-the-shelf hardware, you can just create a cluster very, very quickly. You can let Ignite manage the complexity of the cluster computing for you, okay? It is something that you as a developer don't have to worry about. Less for you to worry about, okay? The burden is kind of removed or lessened, okay? I won't say it's 100% removed, okay? That's not going to happen anytime soon, but still things that you have to think about are going to be important. But if the system can do far more for you, that's going to really help you. And I think typically today then, it's about the business problem. Technology kind of takes second place. It's just an enabler. It just lets you do things, okay? But there are things that you have to worry about. What is your organization trying to do? Are they trying to make more money? Are they trying to be more competitive? Are they trying to identify new look at threats and opportunities? What is it that's the business case that they're looking for? And these are the things that we should be focusing on at a higher level, rather than worrying about the underlying tools and technologies that we use. Okay, so So one of the things that they've done with Ignite, and again, if you're familiar with Java, you know that garbage collection can be a big problem, specifically when you're dealing with large quantities of data, large amounts of memory. So with Ignite, what they've done is essentially it's got its own memory management system. Okay, so they've offloaded as much as they can. So the Java has to do, you know, the garbage collector has to do the least amount that is required. Okay, that really helps. Because of this approach of providing persistence capability, I mean, it says there, store superset of data. Superset maybe is not the correct phrase. So essentially, all of the data can be stored on disk. Some of the data can be cached, okay? So for example, you might have terabytes or petabytes of data. Probably you're not going to have petabytes of RAM. RAM is going to be much smaller, okay? But you want to be able to page in some of that data to be able to process it. And so that kind of makes sense. Okay, so you're storing all your data on disk. You use what you need in RAM to be able to get the benefits. So this durable memory, as they call it, okay, the ability to store data, persist it beyond the lifetime of the process that created it. Other things, because it's got its own memory management system now. And by the way, this is all open source, okay? So if you want to know how this works and you're really interested, you can get all the code, you can poke around in it and see how they've actually implemented it, okay? I'm not that smart, okay? You guys are probably much smarter than that, and you can do that if you want. So, predictable memory consumption. Transactional, write-ahead logs, okay? So if you're familiar with how database systems tend to work, and maybe you've worked with things like Cassandra, for example, these type of technologies use this kind of logging mechanism. So in-place updates can be expensive, all right? So what you typically do is you append data to a log. Periodically, you flush that, as they call dirty pages, you know, they are persisted. You free up the log space, okay, and then you've got the ability to continue doing some additional processing. One of the other benefits that it provides is instantaneous restarts. Well, probably defeats the laws of physics, but it's very fast, okay? So because of this logging and other capabilities, in the event that the cluster crashes for some reason, or say part of it goes down, it's very easy to bring it back up again because of these, you know, logging capabilities and other features that they've added. Some good benefits there. Excuse me. Okay, compute grid. So this is one of the oldest components of Ignite. And typically then this type of approach, if you're familiar with fork join, you know MapReduce, this is very, very similar, okay? And again, the capabilities here are very important to the machine learning, which we'll talk about very, very shortly. So here, I mean, all that's happening is all the standard things that you would expect in cluster computing, such as load balancing, automatic failover, all those guarantees are provided for you. As jobs come in, they're just broken down, parallelized, based upon the resources that are available in the cluster. In this case, we happen to have two servers of equal capability and equal processing power. So this job is completed, you know, in time, t divided by 2, okay? Because we're just parallelizing and then using those resources equally. One very useful feature, if you're a Java developer, up there it says zero deployment, okay? So Ignite provides this capability. It's called peer class loading, okay? Very useful. Be careful though, you know, with great power comes great responsibility. So use it in testing systems by all means, okay? Be careful in production systems, okay? So essentially what it is, as you're modifying your Java code, rather than having to shut down the cluster and bring it back up again because your code has changed, that code is automatically deployed for you. It's automatically propagated to the servers. They know what your new code does, all right? And in some situations, you know, in testing environments, that's great because you may have sort of limited resources, limited time to be able to achieve what you need to achieve. In production environments, you don't want this necessarily to happen. You know, a simple mistake, for example, can have dire consequences for your cluster. And just to give you a slight sort of tangential example, not related to peer class loading, but an example from real life, there is a customer using Apache Ignite. a developer wrote some SQL code, it set the balance of all customers to 0, okay? So their bank accounts, and that's a programming error. Now, Ignite won't stop you from doing that, okay? But there are checks and balances in development environments. They were not followed. The correct processes were not followed. And unfortunately, the live system, someone wrote some SQL code to do this terrible thing, okay? Customer's not very happy, okay? So there are things like snapshots and disaster recovery, which are kind of enterprise features, okay? So those are offered by GridGain. So the client happens to be using those capabilities. So very quickly they realized what the problem was. They were able to restore the system to a working state again, okay? So these things happen in real life. We're human. We make mistakes. We are developers. We don't always get everything right. So something to be aware of. Very useful, but just be aware of that. Okay, so in terms of the actual machine learning grid then, so last year this was in beta. In release 2.4, it went GA. And so what they provide is distributed core algebra, okay? Dense and sparse algebra, linear regression, classification. Okay, we'll look at some of the examples very shortly. At the moment, there is obviously support for Java, C++, .NET. There's a REST interface as well. Support for R and Python, it's on the roadmap, okay? Python is kind of moving along faster than R at the moment. And if you're using things like TensorFlow, for example, watch out for that, hopefully coming in 2.6, okay? That's a few months down the road, but that integration will come along. All of the capabilities that Ignite provides, for example, using co-location, using this kind of extra information that it has to help improve performance, these distributed machine learning library can utilize that knowledge as well. Key thing to notice is that these algorithms have been written from the ground up to make use of Ignite's distributed capabilities. There's nothing to stop you from using third-party libraries if you want. You can do that. But because Ignite, it sees them as a black box. It cannot look inside to see the implementation. They will just work on a single node, okay? With these machine learning library, you have the option. Either you can run it locally or you can run it distributed. It's entirely up to you, okay? The choice is there based upon your needs, based upon the use case, whatever is the business case for doing so. That's your choice. And a key benefit, no ETL. Now we don't have to extract the data out of the system to be able to use other tools to train the data, create models. All of this can be done in place inside the system. So all of the data that you're storing in there, again, creating these models and training the data, that capability is built in. All right, now, let's just take a step back, and I'll show you there's a couple of important things that they've added to how this machine learning works, okay? So we talked about key value, okay? So typically, the way it stores this, and again, if you're familiar with things like Redis or other key value type stores, this should look very familiar. So the idea is that with a key value, you take the key, you apply some hashing algorithm to it, and then that gives you an address. You have a space to be able to allocate, which particular node that bit of data is stored on. Ignite obviously uses this notion of caches. I may have mentioned that a few times already, okay? But think of a cache just like an aggregate, a collection, like perhaps the equivalent of a relational table, for example. The actual unit of storage, though, is a partition. Partitions are atomic, okay? They can't be broken down. And then this is what actually gets stored on a server node, all right? And then typically then, if we look at the big picture, it's kind of like this, okay? So think of the cache as the outer container, and then within that we have partitions, and then we're actually storing, based upon the hashing algorithm that we've applied to the key, the values that are actually going in a particular partition. And here we happen to have two of them, okay, stored. And we might split this, so that might be on one node, that might be on another node. It depends, okay, what sort of topology we've decided upon and how much data replication we want, okay? Often, I think within distributed environments, it's not uncommon that you have like a primary copy of your data somewhere, and then you have a backup copy in a separate part of the cluster. So in the event that the primary goes down, the backup is available. It can help answer the kind of questions and queries that you want to do until that primary that went down can be replaced. Okay, so backup copies. So here we've got sort of 4 partitions, very neatly organized on a 4-node cluster. Okay, 0, 1, 2, 3. And in this scenario, then suppose we lose a node. Okay, then all of that data is gone. Okay, it's no longer available to us. And therefore, just creating these backups, here we go. Okay. Other things, so there is rack awareness as well, okay, and some other sort of interesting things that you can do to ensure that you are not storing your backups in the same rack. If the rack goes down, you lose your backups as well. There's nothing to stop you making a backup of all your data on every node. Not very sensible, particularly if you've got large amounts of data, but as I said, typically in distributed environments, it's fairly common. I think you have a primary and a backup copy somewhere. And with Ignite, there is no master, okay, in the sense of a master node or anything like that. It's a peer-to-peer system, okay? Yes, there is a primary copy of the data, okay? There is a node that is responsible for that, but they keep a backup copy somewhere else. And then, for example, here in this scenario, we've got our primary and we've got backup copies in gray of these partitions. In the event we lose one of these nodes, then here we can see that we still have the data available that we've lost. Okay, so quite a useful feature. Now, the reason that I covered this specifically is because with this latest release of Apache Ignite, they now provide this capability called partition-based data sets. Okay, it's quite a clever thing. So it's like an abstraction layer that sits over the storage and computation and under the actual machine learning algorithm that you're trying to run. So the thinking here is that often, when you're working with machine learning, algorithms, many of them are kind of iterative, okay? And as it's iterative, the context of what it's actually working on changes, all right? So what this partition-based data set can do, it can preserve that context. If some part of your cluster goes down, it doesn't mean that that job has to be abandoned, okay? It can recover based upon copies of the partitions that have been stored elsewhere, that have been cached elsewhere, okay? So graphically, we can kind of visualize it like this, okay? So there's context and data. So here we've got 2 nodes, okay? Node 1 has P1, partition 1, and node 2 has got partition 2. Each of them have got context and data, okay? So as we're maybe doing some training, okay? Now it says they're reduced, so it's map reduce like, okay? It uses that kind of technology. It isn't map reduce per se, okay? So we can then apply this, and then again, because it's an iterative thing, and things in machine learning will tend to work a little bit like this, okay? So in the event that there is a failure, suppose that we lose a partition on one of these nodes, it can recover both the context and the data, okay? So very, very useful. And then I think particularly in distributed computing, sometimes things are a little bit unpredictable, okay? There can be delays, network outages, hardware can fail. And I think particularly if you're running these kind of algorithms over perhaps larger sets of data, for which a parallelization and cluster computing makes sense, then obviously if you've been running a job for say half an hour, 45 minutes, an hour, and then something catastrophic happens, you've lost your work, okay? So what this is trying to do is to really mitigate this and help the system to continue working despite the fact that some parts of your system have gone down, because it preserves context and data, okay? It's a very useful feature. Okay, so in terms of what does it support then, in terms of algorithms? So I've just basically summarized here. So classification, nearest neighbor, decision tree classification, neural network, regression, linear regression, decision tree regression, nearest neighbor, neural network again. For clustering, k-means, and there's some pre-processing normalization as well. So the approach that they've taken with this is not to support hundreds of different types of algorithms. It's a very kind of practical approach, very much driven by the kind of problems that users see for real-world applications. And I'm sure others will be added in time as there is enough demand. And again, remember, because it's a community-driven project, it really depends on where the community feels the effort should go. Because even in community-driven projects, resources are finite, okay? There's only a certain number of people that can work on the project, and therefore, you have to take a decision to say, what are the priorities? What are the things that we really want to work on? What do the users really want, okay? So there is some level of support. It's a very practical, very pragmatic type of approach in terms of what they're offering today. As I mentioned, other things will come along as well, better support for these type of data science type languages, Python and R in particular, and TensorFlow as well, which is coming along as well, hopefully in 2.6. Okay, so very quickly, just show you a quick demo, and then we'll just cover genetic algorithms very quickly, a couple of slides on that, and then we'll just wrap it up there. So all I've done here is I've just downloaded the source. There are binary versions of Ignite as well, but I happen to like getting the source. I've loaded into my IDE. I've built the project, and with Ignite, they provide quite extensive examples of not just on the machine learning part, but how to use the compute grid, key value, do put get operations, how to create caches, for example, SQL examples. Okay, so all of these are provided. You can have a look at them in your own time. And so for this particular one, if we just zoom in a little bit here, you'll see that I'm working on a little bit of code here for the iris. Okay, this is the classification problem. But if we just go down over here, and then I can just quickly show you some of the examples. So here we can see, they provide k-means clusterization example. Now, all of these in Java, okay? There's some Scala code as well in here, but I don't think the C++ or .NET comes as part of this distribution. There are, I think, separate libraries available, which, again, just ping me and I'll be able to trace those down for you. Okay. Notice here as well things like persistent stores, service grid, streaming. Okay, so the examples that cover everything that we've talked about today. And as far as the particular algorithms here, again, you can have a look. See, linear regression, number of different types of trainers with normalization. There you can see Titanic example, something that I've been just sort of working on in my time over the last couple of weeks as well. So all of these bundled with the project, all right? There's nothing particularly exciting that I can show you that would, although maybe we could do something like this, for example. So let's have a look. One of the nice things about this is that, particularly with the machine learning, the examples are standalone. Basically, they will work without the need to fire up a cluster. You can do that, okay? You can fire up a cluster directly within the IDE, all right? And then the way that the defaults are set up, you can have a number of nodes up and running. Just depends on the resources of your machine, how it's configured. And again, you can run these examples if you want. But for this particular one, I can just run it straight from here. And it's like a client application, okay? It just fires up, creates a cache, loads CSV data in, stores that in the cache, creates a model, and then we could actually do some additional work with that model. So you can see it's pretty fast because it's not really taxing this particular system. So in this case, it's just giving me the ground truth, predicted sort of cluster versus what is the actual label for that. Okay, classification example, very straightforward. All right. So as I said before, nothing particularly exciting. I mean, generally with this type of thing. Now, you're probably wondering about things like visualization, and if you work with things like Python, Matplotlib, all of these great libraries that you have available, you can plot things. They show you things in a visual way, which is far more useful than just looking at code. Again, adding these capabilities over time. So what they've done at this level is created the foundation, if you like, support for the algorithms, Next stages is to enhance those, improve those, add additional capabilities. TensorFlow is one of them, but again, give you the opportunity to be able to do far more useful things, be able to create visualizations, if you like. And if you're thinking about GPU support as well, again, that's on the roadmap. Okay, so these are things that are planned. All right, now. A couple of slides to go, and then we're done. Okay, so let's have a look at genetic algorithms. So when I started looking at this, I didn't know anything about this. So it's quite a kind of interesting thing. So you have this notion of a population. So what it's trying to do is just simulate biological evolution. You have chromosomes. Chromosomes consist of genes. Okay, and then you have a solution that you're trying to get to, and then there's a kind of an evolution process. You're modifying. These genes to create new chromosomes. Very, very interesting. We need to kind of assess how good our model is, all right? So there's this notion of a fitness calculation that there's some target that we're trying to reach. We do a calculation, try to compare what we have currently with the target we are trying to get to. Have we reached the target? No, then we need to iterate again. Again, iterative process, okay? Crossover and mutation, again, these are covered in the documentation. Notice this example, very similar to the compute example, the compute grid that I showed you a little bit earlier on. Very, very similar sort of principle in terms of how this is actually working. Again, same kind of notion, using the parallel capabilities wherever possible, co-located computation to good effect. So where data are located and stored together, Ignite can utilize that knowledge to improve the performance and run things much faster. And then typically the kind of the workflow that you use for something like this, you start off with an initial kind of situation, do some type of calculation, have we reached our goal? No. If not, select, crossover, mutate. Now, apologies, it's just a little bit off the bottom there, and if I maybe try and do this, that might help. There we go. So there has to be some termination condition to be able to specify when we need to stop, all right? So there's about 3 or 4 examples that come with the machine learning library, specifically on genetic algorithms, useful for some types of complex problems. Okay? Not all situations, but could be very useful in certain scenarios. And again, that's something that you can have a look at. So let me just switch back to the code here. Okay, so as part of this, let me have a look. Where are we? Here we go, genetic, okay? And just zoom in a little bit. So there's the classic Hello World example, which is one of the articles that I actually took time to write on. There's a couple of others here that you can have a look at. Coin, change, movies. So with this code, I think we don't need a cluster running. We can just, let me just shrink this down a little bit. There we go. Okay, this one. All right, just run it. All right. Just see if that will work. Now the output, I think, is going to be a little bit crowded. It's printing a lot of information messages. Okay, so here it's literally doing the mutation, calculating a fitness score, and then just keep going until it achieves a termination condition and just stops. Okay, so this will keep going for a little while. I think we're almost there. It's 250, 70. There we are. So the last generation is 279. Where it's printed out some information to tell us that, it's achieved its goal of hello world, okay? So, again, encourage you to have a look at that in your own time. One of the things that Ignite provides as well is this web console, okay? So it's a very useful tool that allows you to look at the state of your cluster, how much CPU usage, what caches are there, what resources are being utilized, and you can actually execute SQL queries as well directly from that environment too. And again, one of the blog posts that I've written on the genetic algorithm, which is on the GridGain website and on dzone, it shows you how to fire that up and launch that. You can do that very, very simply. Okay, so I think I'm almost out of time. So I'm going to leave a couple of minutes for questions. So, okay, we've done that. All right, so the key things here, what Ignite is trying to offer is that distributed machine learning, deep learning, when data do not fit within a single server unit. So it gives you the benefit of utilizing cluster computing, utilizing the resources available, parallelize the work, make things run faster. Zero ETL, that was a problem in the past. Today, everything can be done within Ignite itself, which is useful, okay? Massive scalability. So I think some of the largest Ignite clusters out there, Spurbank is a good example. They've got lots and lots of clusters, terabytes of RAM for each node, and they've got some of the kind of commercial features that GridGain provides as well, things like data center replication, disaster recovery, all these kind of capabilities as well. So they've got a few of these around the world. In the event that one of them gets knocked out, it's okay, you know, the system will still work. So huge amounts of data being stored. Now, with Zookeeper added capability recently, potentially your clusters can scale to thousands of nodes if that's what you want, okay? So massive scalability, horizontal and vertical, RAM plus disk, okay? So the ability to persist data, okay, which again can save state, it can save a lot of time having to recover your system again, because as you know, when things are held in memory, unless you have some kind of backup power supply or there is some other contingency that you've made, if there is a catastrophic failure, the cluster will collapse and it will go, you have to provide some additional backup in these situations. Fault tolerance, continuous learning, partition-based data set. This is a kind of a new feature, kind of very useful again, because context changes. A lot of machine algorithms are iterative. We don't want to lose the work. And even, I think, using modern technologies, it can still take time. If you're looking for things like conversions, for example, it can take a while. Even using parallelism, the resources of cluster computing, you may have committed yourself to, 15, 20, 25, 30 minutes of time. That could be very valuable. And I think particularly in the world that we live in today, where business decisions have to be made very quickly, people are looking for answers, in minutes and hours, rather than weeks and days as they did in the past, because opportunities, threats, it's a very changed world. So providing these capabilities, I think, really helps a lot of businesses. Okay, great. So I think we've got some time for some questions. Happy to answer any that I can. If I can't answer anything, I will be happy to follow up and provide you with the relevant information. So I hope that was useful for you. Maybe you've learned a few things. And if you're not familiar with Ignite, even just knowing about it, I've done my job. Okay, so that's great. I can tell my boss that 20 people know about Ignite that didn't know about it before. So that's the key thing. It's a fabulous project. I think at Apache, it's amongst the top 5 most active projects, both in terms of contribution and the activity on the user and dev lists, which you can sign up to. And they've got fabulous resources on there. So people come along, and I think there's actually people complaining inside GridGain saying, why are we providing such good support on the user and dev list? Customers should be paying us money for this. But that's the quality of support that you're getting for this open source project. Okay, great. All right, thank you.